Hello, everyone. Welcome. My name is Seth Eliot. I currently work for AWS for WellArchitected, and we'll talk about what WellArchitected is in just a bit. But I actually joined Amazon in 2005, and in 2005, I was working for Amazon.com, what we call the consumer side, which is what we're going to be talking about today. We're going to discuss a little bit of history of Amazon.com and how its technology has evolved and how it reliably scales in the cloud today. And to do that, we need to go back to 1995. Here it is, 1995. There's the Amazon.com site in all its glory. This is an age before HTML tables were a thing. So this is what the website looked like. Kind of hard to believe how far we've come, but it was a modest beginning and a successful beginning. And when we launched with this architecture. So this is also a rather modest architecture. I want to draw your attention to a couple of things here. So that thing that says Overdose. That is a single binary, a single C binary. Later, it was made C++, but it was originally launched as a C binary running on a single server. And that single binary was calling a database, an Oracle database, also running on a single server. So yes, Amazon.com launched on 2 servers. That database was called ACB. ACB stands for Amazon.com books, and everything was in there: customer data, inventory data, order data, what have you. And that was basically it. I mean, when you ordered something, Overdose processed the order, and it eventually the distribution center was notified of it and sent a package, and that package went to you. The only other thing you see on here is this CC Motel. That's credit card motel. It was called that because credit cards could check in, but they couldn't check out. Even from day one, security was utmost importance at Amazon. And the way CC Motel worked is you could enter credit card info, but you can never retrieve it. But the CC Motel, which was under lock and key, literally under lock and key, you had to actually have special access to get access to it, would then process the financial transactions. So as I said, Overdose was a single binary. This is what we call a monolithic architecture. And in a monolithic architecture, every feature, every piece of business logic goes into that binary. So for instance, we launched Buy Now with one click. When that was launched as part of Overdose. The changes were made to Overdose. The developers had to change the code in Overdose, had to build it, and had to deploy it. So this has some downsides. Number one is we're trying to get big fast. That was our big motto back then. You could see 1997, one of the T-shirts from one of our picnics there. Get big fast, have another hot dog. But yeah, running from a single web server, hitting a single DB instance, making direct calls in the database was not going to help us get big fast. Because as you made those changes in that one monolithic binary, guess what? You were also dependent, tightly coupled to other people making other changes. You had to wait for the deployment to happen, and if anybody else's changes broke the build or held up the deployment, you were held up too. And as you can see here in this fourth bullet, the binary grew. It eventually became a C++ binary and grew and grew and grew as we added business logic until it was a gigabyte after it was stripped of debug information. So that meant because it was stripped of debug information, if there were any problems, they were super hard to solve. And if you're a developer creating functionality in this monolith, and you had to build it on your desktop, of course you had to build it on your desktop before you would deploy it. That took 12 hours. So, build it and then go to sleep and come back the next day. All of these were not a recipe for agility. All of these were not a recipe for rapid innovation that Amazon was known for. I found this quote on one of our internal wikis. Now, our internal wikis are used across the company, and wikis are forever. And this one's from year 2000, and it says, Overdose no longer links on Red Hat 6.2. The linker blows up when its memory usage reaches between 2,000 and 2,100 megabytes. So, and then it went on to explain how you had to then strip the binary. Overdose served us pretty well. And the other thing I guess to know about Overdose, other than it became a bottleneck, is that Overdose followed our convention at Amazon of naming things after locations in Brazil or words in Portuguese. And Overdose is the narrowest part of the Amazon River. So being the narrowest part of the Amazon River and becoming a bottleneck, it was sort of a self-fulfilling prophecy. So what we actually needed was scalability. And if I'm going to say we need scalability, I should define it. I think we all understand what it is, but defining scalability, it's the ability of a workload to perform its agreed function when the load or scope changes. We needed that because to get big fast, we had to scale up to that big audience of consumers we wanted to serve and the big number of items that we wanted to support in our catalog. So around 1998, we started looking at how do we actually make our architecture more agile, more responsive. And we started with the databases. So on the left, you can see the Web1 database. We split out the orders information into the Web1 database so that when you're doing an order on the website, you want it to be fast. You don't have to wait for your order to process. So that can be all processed by Overdose quickly in the Web1 database. And later there was a Web2, Web3, Web4 database. And then later, the information in the orders database, the Web1 database, was synced back to ACB. So ACB was still this big primary master database. It was synced using Oracle's native replication capabilities. And similarly, if you look at our distribution centers, which were later renamed fulfillment centers, we call them fulfillment centers now, but back then they were called distribution centers. Back by 1998, we actually now had 2 of them. We doubled the number of distribution centers. And each one of those was similarly given a database so that when items were picked and shipped, it can go into that local database and then be synced back to ACB using the native replication. So this helped a bit. A little peek into the future. As of last year, we had over 175 fulfillment centers, and as of last year, we had over 300 Oracle databases serving those fulfillment centers. Keep that in mind. I'm going to tell you a little story about that later and how that's no longer the case. Okay, so now we're in the year 2000. SOA is service-oriented architecture. And in 2000, our engineering leadership actually wrote a memo called the Distributed Computing Manifesto. And in it, it said, hey, this monolith is not serving our needs anymore. We need to think about how to break into smaller services. We shouldn't be making direct calls into the database. Everything should go through an API. The different domains across the company should be split up into different services. So ordering looks different than fulfilling, looks different than rendering the website. These all have their own primitives and should be treated as such. So the manifesto helped drive a re-engineering effort where we started to break services out of Overdose. And the first one we broke out was called the Customer Master Service, or CMS. So basically that started as just a thin layer over the customer database. We had the customer database, we could make a thin layer over it just to turn the SQL statements into API calls. But over time, Customer Master Service took on a lot of the business logic associated with customers. And you can see in ACB, there's orders and inventory. You can guess what happened. That, there was an order master service and an item master service that followed after that. So this is our first re-architecture into service-oriented architectures. And ultimately, Amazon did get big. This is as of last year. By some measures, we're processing 40 billion requests a day, 15 petabytes of dynamic content processed per month, and we're hosted in 18 countries. So we did get big. How did we do that? Well, fast forward to 2020, and you might be surprised to learn that our architecture looks appreciably like it looked in 1995. Okay, you should be saying, what the heck, all right? That was a joke. That was to see if you're paying attention. No, our architecture looks like this. There's our architecture. What are you looking at? It's very pretty, but what are we looking at here? This is, every dot on this diagram is a service that's running the Amazon.com website and systems. And as you know, services have dependencies. They call other services. To show that, we're actually connecting the dots using lines. And it's almost impossible to see in the middle of the diagram. At the edges of the diagram, you can sort of see the lines there. So I zoomed in on one part of the diagram. I picked a service pretty much at random, and to show you that indeed there are lines in this diagram. This is a service that is being called by over 300 other service clients. So this is what our architecture looks like now. How did we get from point A in 1995 to point B in 2020, and how did we achieve this? Well, as I said, we needed to scale, but why did we need to scale? We needed to scale ultimately in order to be reliable. So let's talk about reliability. Reliability is the ability of a workload to perform its required function correctly and consistently over an expected period of time. In other words, be available to our customers. Our customers want to look at stuff, we're available. Our customers want to buy stuff, we're available. They order stuff, our fulfillment systems are available and ship it to them. So that's what reliability is about. And if we're going to talk about reliability, I want to talk to you about the AWS WellArchitected Framework. As I mentioned, that's the team I'm on. The WellArchitected Framework is a way to learn best practices, to then measure your workloads and systems against those best practices, and then to improve your workloads and systems. So it consists of 5 pillars. We're going to be talking to you today about the reliability pillar. We're also going to be talking to you about the operational excellence pillar. These two pillars are going to be the main focus of today's talk. There also is security pillar, performance pillar, and cost pillar, all important, but not the focus of today's talk. And the way the well-architected framework works is that you learn because we publish white papers, we create labs, and this is a way to teach you and show you what the best practices are in these pillars. Then you measure using a well-architected review. A well-architected review is a way to review your workloads and systems against these best practices using the well-architected tool. The well-architected tool is something that's free to use. It's available in your AWS console today, and it asks you questions about your workloads, and then you answer yes or no, I'm doing these best practices, or I'm not doing these best practices, and it will give you an improvement plan. So that's how you improve. And we're going to be showing you screenshots from the well-architected tool all throughout this presentation. So let's dive in and talk about what do we mean by service-oriented architecture and microservices architectures. Hint, you can see in the subtitle there, it's about breaking down the monolith. So the monolith is shown on the left. Monolithic application does everything. It shares the release pipeline. Everything's tightly coupled together. It's Overdose is a monolithic application. Now on the right side of this diagram is the other far end of the spectrum, microservices. Microservices each do one thing. They could be deployed independently, they could be built independently, they could scale independently, and they talk to each other through events or APIs. Okay, so that's pretty clear. So what is this whole service-oriented architecture thing? Well, it's kind of in the middle, but kind of not. So you can see each service does some things. Let's talk about what that means exactly. What is the difference between SOA, or service-oriented architecture, and microservices? Well, service-oriented architecture is really about how we architect the enterprise. So if you think about all those things like orders and customers and fulfillment, these are all applications. And each of these applications should be served by its own service. And that's what SOA really is. The other thing about SOA is there often is some intelligent service bus that contains some business logic that determines how these services are called and when. Now, this is SOA. Now, if you take one of these applications and break it down into multiple services that each do one thing within that application, that's what microservices are. And microservices are typified by not needing a service bus. They just talk to each other through APIs or events. Now, at this point, you might be thinking, is Seth going to say we need to be microservices or we need to be SOA? I'm not going to say either one. SOA and microservices are both good. Moving away from the monolith, breaking things down into smaller pieces is going to benefit you. And that's really the goal of this talk today, to show you that. It's not to convince you SOA versus microservices or even worry about one or the other. It's to show you how breaking down the monolith is going to help you. So let's talk about how do you break down a monolith into smaller services. And Martin Fowler came up with something called the Strangler fig application pattern. I think this is pretty interesting. And he said you gradually create new systems around the edges of the old, letting it grow slowly over several years until the old system is strangled. So you can see the Strangler fig plant is on the left. It actually puts down vines around an existing tree. That's not the Strangler fig. And it puts down more and more vines until the existing tree dies, and all you're left with is the Strangler fig. And this is what we're saying you should do with your monolith. So when you have new features that emerge, new business needs that emerge, and the monolith is not agile enough to meet them, you instead create a smaller service instead of the monolith. Over time, you start assessing the monolith, what it's doing itself, and looking at the functions it's serving, and break those out as separate services. You do that over time, and eventually the old monolith is hollowed out, and there's nothing left of it, and you can deprecate it. And that is what happened with customer master service, item master service, order master service. None of them are around. They were all ultimately deprecated, but it took many, many years for that to happen. Now, while that was happening, Overdose was actually happily serving us from 1995 through 2005. Yes, it did grow to more than one server. We actually had it, on multiple servers in multiple data centers around the Seattle area. So it was serving us pretty well, but not well enough. You can see that in 2004, we had a major outage. Our agility was the big problem, though. As I said, Overdose is a bottleneck. And as we added things other than books, we started with just books, but as we added, let's say, music, and we sold CDs, I know CDs are already out of date, but we sold CDs, you would have to like be able to show what was the number of tracks on the CD or what the genre of music on the CD. That was called a product attribute. And adding a product attribute took a month. I remember when I started in 2005, how frustrating this was that it took so long to add product attributes. And you can see the other numbers on there that somewhat are astounding, how long it took to get things done. So Overdose served us well, but we needed to replace it. So along comes Garupa. Garupa was developed throughout the early 2000s and launched in 2005 and replaced Overdose in 2005. Now, unlike Overdose, which is the narrowest part of the Overdose Amazon River, Garupa is actually the section of the Amazon River where the tributaries diverge. And this is a very appropriate name because basically, if you look at what it's doing here, it's a page assembly engine that calls hundreds of back-end microservices to assemble pages quickly. Let's take a look at that. So as I said, it's a page assembly engine. It's making hundreds of service calls per activity. So activity means like to show you a detail page on Amazon.com. It's calling hundreds of services. Now, those backend services, we call them widgets, were written in an interesting language called Perl Mason. So yes, when I joined Amazon circa 2005 through 2007, 8, I had to do a little bit of front-end work, not much, and I had to learn how to write web pages in Perl Mason. So this was an interesting choice, but was a choice that was made. And it's just funny to think that throughout the 2000s, the Amazon site was basically served using Perl. But the nice thing about it is it forced the business logic down into the services. So Garupa could just, be kind of this front-end page assembly layer, presentation layer, but all the business logic is in the back-end services. And so let's talk about what that looked like. So this is what a detail page looks like. This is the Kindle Fire detail page, and it's where you'd learn about the price and the title and the picture of the tablet, and you can buy it. You can obviously buy it on this page. Now, if I zoom into a part of this page, you can see how it's making many back-end calls. So you can see on the left, it's calling the image block service. On the right, it's calling the title service. Yes, there's a service that actually determines what the title should be. It's calling the ask service. It's calling the AC badge service. So it's calling all these back-end services to assemble the page and do it very quickly with low latency in parallel to render the page for you. So that illustrates how it's making, and if I showed you the entire page, you would see there are hundreds of service calls. It just got too crowded. So I'm just zooming in on this part of this page. Now, just so you know, today we are not writing new pages in Perl. Yes, actually, Garupa is still around. Garupa is not fully deprecated yet. And yes, there are still some pages using Perl Mason, but generally we're moving away from that, and our developers have a choice of more modern technologies like Spring, Ruby, and Node.js to write their pages in. And let's not forget about the backend. So there are many, many backend services that are calling each other to make things happen on Amazon.com. And to facilitate that, since they're microservices, they need to be able to call each other independently of a service bus. We do have internal frameworks that facilitate this. The internal frameworks basically let developers define an interface definition language that developers use to define their APIs. And that way, clients can call services in a language agnostic way. So if I write a service and it's running in Java, I, as a client of that service, are free to use Python or Ruby if I want and still be able to call that service. So this facilitates the ability for services to call each other. It also facilitates not only the API definition, but the API discovery. So what I'm going to do throughout today is show you snapshots from the WellArchitected tool. Remember, the WellArchitected tool is free to use. It's in the AWS console. It's where you can go to review your own workloads against AWS WellArchitected best practices. But the reason I'm going to show you snapshots from the tool is after I talk to you about a certain concept, I'm going to show you where in the tool we talk about those best practices. If you want to learn more about those best practices, you can actually go to the white paper, the reliability white paper, or the operational excellence white paper, where it'll talk about those best practices in even more detail. So here, to illustrate what we just talked about, microservices and SOA, I want to draw your attention to the reliability pillar, to reliability question 3, where it asks, how do you design your workload service architecture? And specifically, it asks you, tells you you're building reliable workloads using a service-oriented architecture or microservices architecture. And those best practices, you need to know how to segment your workload so you can break it down and then build your services focused on those specific business domains or how you broke it down, either using SOA or microservices. So let's talk a little bit about DevOps and how it ties into everything and how it ties into Amazon's success. So if SOA and microservices was breaking down the monolith, DevOps is about breaking down the barriers between dev and ops. So what do I mean by ops? Let's talk about classic ops. And I'm talking about classic ops. I have a question mark there because everybody does this a little differently. So this is sort of a very high, broad generalization of ops, which is these are phases that most software goes through. It's developed, it's deployed, it's operated, and then the users use it. And then we look at how they're using it. We look at the data and we adjust and we, if there's bugs, we fix them, or if there's certain use cases that are interesting, we'll adjust to those and develop and iterate. In the classic case, there's a wall. There's developers doing development and deployment, and then ops folks doing operations and then working with the user data. This wall doesn't have to be here. It could be further left even. In some organizations, the ops folks do the deployment, developers don't even do the deployment. So that's a classic ops structure. So then what is DevOps? It's important to know that DevOps is a culture. Yes, we could talk about tools and practices, but really it's about a culture and everything flows from the culture first. So as I said, I started at Amazon in 2005. And when I started, I was handed one of these things, a pager. Since then, pagers have been replaced with phone apps, but I was handed a pager because I was expected to own the services I worked on, not only through development and deployment, but through running in production. And we took turns, and we still do take turns, being on call so that if a problem emerges in the middle of the night, we're there to fix it. There's no ops team to do that for us. Now, I did a bit of a search, and forgive me if I'm wrong, but I found the first use of DevOps as a term in 2009. So in 2005, I started at Amazon. Before I started there, people were using pagers, I assure you. So Amazon's been doing DevOps as a thing long before DevOps as a term came to the fore. And as I said, I want to show you in the WellArchitected framework our best practices that illustrate what I just talked about. So if we're talking about DevOps and carrying a pager and ownership and being responsive, let's take a look at the operational excellence pillar and how you operate. The question is Ops 10, how do you manage workload and operations events? And these are all best practices. But if you look at here, define escalation paths. Well, guess what? If I did not answer my page, then my manager would be paged. If she or he did not answer their page, then their manager would be paged. And theoretically, the process was ultimately Jeff Bezos could be paged if everybody dropped the ball along the way. That did not happen very often, thankfully. And enable push notifications. Again, carrying that pager was a very, very explicit form of push notification. So DevOps is very well aligned with Amazon's culture. As I said, DevOps is a culture. Amazon has a culture. Amazon has leadership principles. You might have heard about our leadership principles. So to look at that, let's define DevOps a bit. What is DevOps? DevOps means the team owns both the software development, the dev part, and the IT operations, the ops part. Well, if you look at our leadership principles, we have one called ownership. The ownership principle says, never say that's not my job. And that fits very well with what I just defined as what DevOps is. But why do DevOps? Because we think we can deliver and prove value to the customer at a faster pace reliably using DevOps. And that fits really well with our customer obsession leadership principle. Start with the customer and work backwards. So one of the ways Amazon facilitates DevOps is through our organizational structure. And you might have heard of the two pizza team. So the two pizza team is a cross-functional team at Amazon that is no bigger than can be fed with two pizzas. So that means about 8 people, but it varies, plus or minus. And two pizza teams are fast and agile because of the following. Because A, they have full ownership and autonomy. They own the services that they create and they deploy and they run, and they have pretty much full autonomy to implement those services and add features to them and control how they're developed and deployed. And as I said, they build it, they run it. Okay, that's pretty much DevOps in a nutshell, right? They're not handing it over to somebody. They're not throwing it over the wall. The nice thing about you build it, you run it, is that if you build it let's say poorly, maybe that's not the right word, if you don't build it as well as you should and you deploy it to production and it causes you lots of operational pain, you're feeling the pain. So it's a direct feedback mechanism to fix that and make it better. And focused innovation. So our two pizza teams are deeply knowledgeable of the domains that they own. So for example, I worked as a principal engineer for the Amazon Fresh team. That's our grocery delivery service. And one of the microservices there handled availability. Is this milk available for the customer to buy? And they may sound pretty simple, like, okay, let's count the number of milk cartons in the fulfillment center and see how many have already been allocated to use, people who bought them, and give you an answer. But it's not simple. Okay, number one is people, for when they buy on Amazon Fresh, are now scheduling deliveries for some time in the future, either in 2 hours from now or 2 days from now. And guess what? Milk spoils, right? So there's something actually in the supermarket inventory parlance called shrinkage. I'd never heard of this before, about things that go bad and spoil and get lost. So to understand whether that carton of milk is available to buy is a fairly complex domain, and this team understood it, down to the very finest detail. I was really impressed by what they knew. And because of that understanding, they are able then to add functionality and features that make it better for our users. And finally, our two pizza teams are free to choose the technologies of their choice. So they can choose to develop their services in their choice of programming languages. However, as I pointed out earlier with those service frameworks, they have a common set of tools for service communication, for build, for deployment, for dependency management that are built and maintained by our developer tools team. So they're not totally reinventing the wheel, they're not totally set adrift. They have the support they need to use the technologies they want. So if you look at this diagram, how do we scale our development and operations? Each one of these bubbles is a service, whether it's a microservice or an SOA service. You can see that now add DevOps to it, it means that two pizza teams own one or more of these services. They have autonomy over this, they own the building of it, they own the deployment of it. Speaking of deployments, because of this, they're independently deployable pieces, each of those microservices. So in 2019, we had 150 million deployments that year in 2019 to production. Quite amazing. And that high deployment velocity translates to the ability to get features and fixes out to our customers as fast as possible. Now, deployment is a dangerous time for any service. That's just simply true across the industry. Deployment is a risky time when you're deploying new code. And one of the ways we address that is with the COE, or correction of error process. If a bug or an issue does happen that impacts our customers, we dive deep on it. We say, what happened? We have supporting data and metrics. I assure you, when you look at one of these COEs, it's full of graphs and data. And what was the actual customer impact? We start with the customer and work backwards, our customer obsession. And then we ask the 5 whys. This is my favorite part. This is sort of like a toddler asking, why is the sky blue? Oh, because of refraction of light. Why does light reflect? Oh, because of the physics of light. You keep asking why to get down to the root causes of what happened. Okay, so in a post-incident analysis, there are multiple root causes. The 5 whys let you dig deep and find out what are the true causes of what happened. Then you could actually understand what are the lessons we learned from this, and this is maybe the most important part: take corrective action. So it's important to know that COE process is not punitive in any way, shape, or form. The COE is a self-correction process that helps us get better. And if you look at the reliability pillar under failure management, we ask, how do you test reliability? We say perform post-incident analysis. The COE is a crucial part of our post-incident analyses. Now, as I said, the COE helps you get better. If the service team is operating their services in production, there's a customer impacting event, the COE is performed, and action items, how do we get better, then are rolled back into the service team operations. It's a cycle where we continuously improve. This is good, but it's not good enough for Amazon. At Amazon, we do this. If you look on the right side, that first cycle where the team's improving is still part of this. However, we have a team dedicated to analyzing all COEs and making improvements to our tooling and to our best practices so that everybody benefits from a COE, not just the team that experienced the COE. And as part of this improvement process, we have a weekly ops review. In the weekly ops review, we indeed do review some of the most high-profile COEs we had, but we also have success stories. We discuss how we want to be positive as well as understand how we can improve. So success stories, there's usually a technical presentation on something that's will affect all services. We review the metrics across the entire website. How is our availability? How is our latency across all the regions we're operating in? And then we do service deep dive reviews. Now, you might be wondering, how do we deep dive on services when we have hundreds of thousands of services? Well, the answer to that is something called the wheel. And the wheel is kind of fun, okay? The wheel is our way of scaling service review. Now, services are reviewed at all layers of the organization. Like a service will be reviewed by the service team, then the organization the service team is part of will have a service review. When you get up to the Amazon.com as a whole, where we're having this weekly ops review, we spin a wheel. And that wheel then lands on a random service, and then that's the one we deep dive on. And all services have to be prepared for them to be the one that comes up on the wheel. And this is part of our leadership principles too. One of our leadership principles is dive deep and stay connected to the details and frequent audit and audit frequently. So when you audit frequently, it's about staying connected to details. The wheel lets us do that, and the wheel has been open sourced. There's the link for it there, and you're free. AWS uses the wheel also. So Amazon.com uses it, AWS uses it, and it's open source. You can use it also. Put your own services on the wheel. So when a service comes up on the wheel, what do we do? Well, we first ask them, hey, what is your service and what does it do? Let's just review that. But what are your service level indicators? What are the most important things you're monitoring that affect the customer? Did you have any anomalies in that? And what were the impact on the customer of those anomalies? Did you have any COEs? What are your current upcoming plans? What is your resilience score? I'm going to talk about resilience score in a bit. And how are you utilizing your infrastructure? How are you utilizing resources? Because this is important also at Amazon. We actually track that. How are you spending? How much are you paying for your infrastructure in AWS? So part of this review is monitoring. Let's take a look at what a monitoring dashboard might look like. So this is one piece of a monitoring dashboard. This is something that's going to be common to almost every service dashboard across Amazon.com. The number of requests that they've received, that's the blue line here, but the latencies are super important. And there are 4 lines there for latency. And why is that? Well, that bottom green line, that's the median latency, or what we call the P50 latency. That is the latency that half of our users are getting that latency or better. That's not interesting to us, because that means half our users are getting that latency or worse. We're much more interested in the P99 or the P99.9. What is that? So the P99 latency, that's the yellow orangish line, is the latency that 99% of our users are getting that or better. Only 1% are getting worse than that. And obviously P99.9 means only 0.1% of our users are seeing latency less than that. This is what's important to us, that we want to see all of our users, or nearly all of our users, experience the best experience possible. So that's why we use the P99. Also on the dashboard is availability. Have you been available to users? Ideally, it should be 100%, 99.999%, 5 nines. How much have you been available to users? Have you been up? Were there any customer affecting major issues? Have you been throttling traffic? How are you utilizing, again, that utilization metric? And this is reviewed on a dashboard across all the regions. Remember that any particular Amazon.com service is going to be deployed in multiple regions to serve our multiple countries we're running in. And teams also have an operational dashboard. So the operational dashboard contains pretty much what you'd expect it to contain in terms of there's a ticket backlog trend, how many high set tickets have you had, how many pages per hour, hopefully low, so you're getting some sleep, COEs, policy violations. This fleet utilization is really what I was talking about before when I was talking about tracking cost. Team, how much we pay for using the AWS resources we're using is tracked at the team level, rolled up to the manager level, rolled up to the director level and the VP level, all on a dashboard. So teams can see how much they're spending, and organizational leaders can see how much their orgs are spending. This is another leadership principle. I didn't write it down, which is frugality, that we only spend on things that matter to our customer. All right, so the reliability pillar talks about this. Just to review, what are the best practices that are most relevant to what we just talked about? Well, how do you design your workload to withstand component failures? Two of our best practices are to monitor all components of the workload to detect failures, that dashboarding and alerting, and send notifications when events impact availability. Availability, understanding those customer impacting faults and being alerted to them immediately, super important best practices that you should be using when you design your workloads and run them in AWS. And I mentioned a resilience score earlier. So resilience score is kind of interesting. It's something that was developed by our reliability team on the Amazon.com side of the business. And all services in Amazon.com can generate a resiliency score, and all tier 1 services are required to generate it. And this is how they generate it. There's 3 pieces to it. Number 1 is, are you doing what we call non-functional testing? So chaos testing means, are you simulating faults and events that could potentially affect your availability, and then validating that it's not affecting availability, that your system resilience is designed to mitigate and absorb these events. Are you doing load testing? We don't do this in production in general, but we do it pre-production, and we then load up to the breaking point, so we know exactly how much load that we could accommodate. But also importantly, after we break the service, break in quotes, we take the load away, and how fast do we recover? That's an important part of resiliency. So whether you're doing these affects your resilience score. We have teams do a risk assessment. This risk assessment is a manual assessment. Teams are asked Q&A, so sounds very familiar to a well-architected review, and it is very similar to a well-architected review. Matter of fact, a lot of the best practices in the well-architected review come from this risk assessment, and they're asked to say, are you doing best practices? Are you limiting retries? Are you doing log file cleanup, etc.? And we have automation. There's a lot of things you can check with automation. You can check, are your certificates valid? Are you doing auto scaling? And all of this rolls up to a score given to the team, and again, rolled up across multiple teams to the director, rolled up across multiple teams to the VP, so they can see how this is being, how their teams and how their organizations are doing with respect to resiliency. As I said, deployment is a dangerous time, and we take deployment very seriously. On the left side of this diagram, you can see speed is critical. This is where developers just deploying to the development environment, a test environment, just working iteratively to get their changes made, their features implemented. But once we cross this line over actually deploying into pre-production and production, there's a very tight, very strict set of rules and tests. We call them pessimistic rules and tests that are applied before you can advance to the next phase. And what I want to call your attention to is that where it says box. You see that box there? This is our 1 box deployment. In our pre-production and production deployments, before deploying to the entire fleet, we deploy to a single box or the equivalent of a single box so that we're getting real consumer traffic, real production traffic, but mitigating the risk to the end user because it's only 1 box, and very quickly assessing, will this work? Is this working the way we expect under full production traffic? And if it's not, that's pretty rare, but if it's not, we roll it back. If it does, we let it bake for a while. If it runs well, then we roll it out to the rest of the fleet with the assurance that it's going to work well for our users. So having just talked about DevOps in general, these are the best practices from the operational excellence pillar that we covered and talked about when we were talking about DevOps. And this is under the organization part of operational excellence, which is Ops 2. How do you structure your organization to support your business outcomes? This is all about the business outcomes. And in this one, the best practice I want to draw your attention to is team members know what they're responsible for. And in our model at Amazon.com, they're responsible for everything that I showed you on that first slide. They're responsible for design, development, deployment, operations, and responding to the users. And Ops 3, how does your organizational culture support your business outcomes? Well, 2 things I want to point out here. Team members are empowered to take action when outcomes are at risk. Again, so if you're paged in the middle of the night, it's on you to take the action that you need. And escalation is encouraged. Now, actually, I didn't talk about this previously, so I want to just address it now. When you have these independent, autonomous 2-pizza teams, well, services have to call each other and work with each other, right? So you will have times where one team needs another team to maybe do something, and that team disagrees that it's the right thing to do. We use the leadership principles to try to decide we're on the right things to do, but disagreements do emerge, and they're legitimate disagreements. Different teams might have different priorities or different perspectives, and we need to actually respect that. But ultimately, if the teams can't come to an agreement on how to proceed, escalation is encouraged. Escalation is not punitive. Escalation is not a bad word at Amazon. It just means that we can't come to an agreement, so we're going to escalate to the next level of leadership. They might have a broader strategic view of things and have them come to an agreement. And obviously, it's rare, but if that level can't agree, it can escalate further even. All right, so I've talked about microservices and service-oriented architecture, talked about DevOps. Let's talk about how we apply this at Amazon. Let's look at some real examples of Amazon.com services. So before we do that, I want to talk about one of the powerful things about microservices is that they could scale independently. And that's super important in terms of being able to respond resiliently to customer need. And at Amazon, we've designed our microservices so that we could share capacity across these microservices. So if you're using EC2 instances, it's a shared capacity pool. If you're using serverless, well, you don't have to worry about it, honestly. So that's already automatically something that you could draw on. And I want to talk about something we launched last year that's pretty cool. It's called Amazon Subscription Boxes. So you could subscribe to a subscription box, like the Marvel box shown here, and you'll be every month be sent a box of high quality items that are in that category, in that theme. You could see what several are themes here. And the team that built this was a very small team. It was just 3 engineers that built that team. They were led by a principal engineer, and they decided to go with a serverless architecture. It's a very simple architecture. It's an API gateway that takes the API requests, sends it to a Lambda, and those API requests are going to be things like, well, what items should I put in this box? Or can you please fulfill this box for me? You know, for this user and this subscription, please fill their box with items and ship it out. That's basically the kind of requests you're going to get. And so that Lambda has a DynamoDB that's maintaining a storage of the users and what their subscriptions are and what they've been sent and what's pending and all that stuff. And the S3 bucket is used mostly for logs. So super simple service. The principal engineer called it a nanoservice, not even a microservice, but handling millions of events a day. And the cool thing about this is that new subscription boxes will come out, like that Marvel one, and be super popular. So they'll have these big spikes in load, and this can handle it. So just, you know, it'll spin up Lambda instances as needed to handle the load, and then spin them back down when they're not needed, independently across user requests and across subscription types. So this is a great way of showing how that scalability of a microservice or nanoservice can operate. And if you want to learn more about it, we do talk about this as an external case study, both on our website, and there's a nice YouTube presentation from, I believe, last year's reInvent that talks about this. So that really talks about managing change using automation. Managing change using automation, in this case, automatically scaling up or scale down in response to load. And this is covered under reliability question 7. How do you design a workload to adapt to changes in demand? And all the best practices there are important. But number 1 is use automation when obtaining or scaling resources. And you can see that the team there, in that case, used Lambda, an API gateway. That's a great choice for your microservices. Another good choice for microservices that teams like to go to are containers. So we have Amazon ECS, Elastic Container Service, and EKS, Elastic Kubernetes Service, that can help you do containerization in AWS. It's a good choice because the container provides a nice little boundary for your microservice, well-defined boundary, and it's very efficient. You could bin pack containers across your EC2 infrastructure to efficiently use that EC2 infrastructure. However, if you don't want to even deal with EC2, you could actually deploy your containers, either ECS or EKS containers, on a serverless framework like AWS Fargate. AWS Fargate lets you get rid of the EC2 instances completely and just worry about your containers. Now, if we're talking about using automation to respond to change and using automation for your workload, I want to talk about how do you manage deployments using automation. And the way you do that in AWS is using CloudFormation. So CloudFormation is what we call infrastructure as code. Infrastructure as code is the ability to provision consistently across different stages. Remember, like you have your dev stage, your pre-prod stage, your production stage, across AWS accounts, or even across AWS regions. So it looks like this. There's a template you define using YAML or JSON that defines what infrastructure you want to deploy, what containers you want to deploy, or EC2 instances, or API gateways, or Lambdas, or what have you. And it will deploy that consistently. We call it a stack across the stages, accounts, and regions, as I just talked about. And the time and attendance service is a service that takes advantage of this. So time and attendance service is an Amazon.com service for our hourly associates. Now, many people that work at Amazon.com are paid hourly, and they have to badge in and badge out to understand how many hours they work. They call this punching in and punching out. That's sort of like the name for it, punching in and punching out. So you can see there's a 5-step business process. And you don't have to worry about what that business process is really. Just know it's 5 steps. You see punch is a word on there. That's why I mentioned punching in and punching out. And we have to actually have a service that accommodates this 5-step process. So we're going to focus in on this one part of the process, 1/5 of the process, punch association. And the punch association architecture was also designed in a serverless way. And what happens is when the associate badges in or punches in, a Lambda sees that punch, calls a state machine using step functions. That state machine pulls some data down from some legacy systems about the employee, and then calls a series of Lambda functions that then basically persist that punch to a DynamoDB table. So it's actually a very similar architecture as a subscription boxes. And when I was putting this talk together, I didn't even realize how similar they are, but it's a very similar, very common kind of architecture. Very simple, very easy to understand. Now, what I need you to know is that this architecture is deployed using CloudFormation. Why is that important? Because remember, there are not just 1 stage, there's 5 stages to this architecture. And here's the entire architecture. It looks kind of complex, doesn't it? But each of these 5 stages is independent. Okay, they each have their independent CloudFormation templates. Each of the 5 stages is owned by a separate 2-pizza team, and they can be deployed independently. Each of these 5 stages is a microservice, communicating with each other using events and APIs, deployed independently, owned independently by different teams, and it's the CloudFormation that managing infrastructure as code that enables them to create this complex-looking infrastructure from much more simple primitives, and that's how we achieve that. So this is about also change management. Reliability question 8 asks, how do you implement change? And the best practice there is to deploy your changes with automation. Use a CI/CD pipeline, use infrastructure as code. All right, another example I want to show you is our so-called warehouses, our fulfillment centers. And Amazon Fulfillment Technologies owns the tech in our fulfillment centers. This is a view of one of our fulfillment centers. I've gotten the chance to visit one, and it's quite incredible. It is actually even more impressive than this diagram, than this picture shows. And until recently, until last year, this is how our fulfillment centers were architected. So there's obviously inventory in our fulfillment centers, and that was stored in an Oracle database. But in the fulfillment center, we're doing many different kinds of operations. We're doing receive operations, stowing, that means putting it on the shelves, picking it back off the shelves, sorting and packing it, and then shipping it off to our users, our consumers. And this was all going through the Oracle database. It was all built up over a series of years, over 300 Oracle databases, some of our oldest databases in the company, really complex, 20+ years of optimization for Oracle, and it was just slowing us down. Okay, so last year, we successfully deprecated the last of our Oracle databases across Amazon.com. So we're no longer using Oracle databases at all. This is what the fulfillment centers moved to. At the bottom of the diagram, the inventory function was moved to Amazon Aurora. Aurora is a relational database service built for the cloud, our specific AWS built for the cloud flavor of RDS. But also important, look at the top there. All these different operations, receiving, stowing, picking, sorting, they all have different needs. Some might need a relational database, some might need a key value store, some may need a document database or a graph database. And AWS has the products we needed, those specialized function-specific databases to do what we need to optimize our services in the fulfillment center. Ultimately, we saw a 60% drop in cost. We saw latencies improve dramatically by 40%, and there was just less overhead for our developers to build and innovate using these systems. So Aurora is a great example of auto recovery, being able to recover automatically from failures. So as you can see here, there's a primary instance that's serving read and write traffic, and there's 3 read replicas that are serving read traffic. just right there, it's actually become more resilient, right? So if we have a failure in one of these availability zones, there's still multiple other instances we could do read traffic from. But if the read-write primary fails, one of the read replicas is automatically promoted to primary. It takes over the DNS name of the primary, and the clients don't even know an issue happened. This is a great example of auto recovery, which is covered in the WellArchitected framework. So under Rel 12, we'll talk about how do you design a workload to withstand component failures? Well, you fail over to healthy resources. That's what we're doing here. We're promoting a read replica and failing over to it, and we automate healing at all layers. That's super important. So in summary, to talk about reliable scalability for Amazon.com, we talked about three main things. We talked about our SOA and microservices architecture. We talked about how DevOps enables that architecture at a cultural level. And I talked about how AWS WellArchitected will help you understand the best practices so you can achieve the same kind of reliable scalability that Amazon.com has. Now, AWS WellArchitected, as I said, the WellArchitected tool is available free to use in the console. If you're an AWS customer and you have an account team, feel free to reach out to your SA or your TAM and say you want to do a well-architected review. They will help you with it. A third option that I would encourage you to look at if you want to do a well-architected review is check out one of our AWS partners. Our AWS well-architected partners are well-trained in the tool and the best practices in it. They can help you not only do a review, but develop a statement of work from that. And you're eligible for AWS credits if you work with an AWS partner when you do a well-architected review. So a very powerful way to get started. I appreciate your time today. Thank you very much. It was a really fun talk for me to give. I hope you enjoyed it. Thank you so much.